Hello my dear student, welcome to another video of the channel MALACHEMPHILIC, and this is video number 136, which is the 75th episode of Chemical Thermodynamics. Here the topic is Thermochemistry Part 1. So obviously it is the introduction video on thermochemistry. So let's start. Under this thermochemistry, what all topics we are going to discuss, that is enthalpy of reaction, enthalpy of formation, enthalpy of combustion, enthalpy of phase change, enthalpy of neutralization, enthalpy of solution, bond enthalpy, Hess's law, Born-Haber cycle. We know that enthalpy H is equal to E plus PV. Okay, and enthalpy is the total heat content or total heat stored in the body at constant pressure, and from here delta H is equal to delta E plus P delta V, that is change in enthalpy is equal to delta E change in enthalpy plus P delta V. Okay, this is nothing but the pressure volume work. Now, from first law of thermodynamics, so from first law, what we know that delta E is equal to, say, heat exchange at constant pressure QP, then plus W, that is work done by the gas or work done on the gas. So, we can write delta E is equal to QP minus P delta V when only pressure volume work for only pressure volume work. This is the equation. So what we can write? QP is equal to delta E plus P delta V, and just now we have seen delta E plus P delta V is equal to delta H. That means this is equal to delta H, or we can write QP is equal to delta H. That means heat exchange at constant pressure is equal to the change in enthalpy. If it is heat absorbed, then heat absorbed at constant pressure goes to increase the enthalpy of the gaseous system. Now, at constant volume, what we can write? At constant volume. Once again, the same equation from first law, that is delta E is equal to, now here it will be QV plus W. So, this is equal to delta E is equal to QV minus P delta V when I am considering only the pressure volume work or mechanical work, but at constant volume means delta V is equal to 0. So QV is equal to delta E. That means heat exchange at constant volume is equal to the change in internal energy. So what we have observed? We have observed that delta H is equal to delta E plus P delta V at constant pressure. But if the pressure also changes, that means both volume and pressure are changing. In that case, what we can write? We can write that delta H is equal to delta E plus P2 V2 minus P1 minus P1 P1 V1. Okay. Now let's see this problem. An ideal gas expands isothermally from volume 10 liter to 20 liter. Calculate delta H. Right. So delta H is equal to delta E plus, here you see isothermally. Isothermally means only temperature is constant. Okay, volume is changing and nothing it's there for pressure. That means pressure also changing. So which equation we should take? Delta E plus P2 V2 minus P1 V1. right? Now we know that for ideal gas, this P1 V1 is equal to P2 V2 at constant temperature. That is Boyle's law, right? Again, at constant temperature, we know that delta E should be 0 because internal energy is the function of temperature. If temperature remains constant, there is no change in internal energy. So finally what we can write? Delta H is equal to your delta E, that is 0, plus P2 V2 minus P1 V1, this line P2 V2 minus P1 V1 is equal to 0. So 0 plus 0 is equal to 0. That is, there is no change in the enthalpy. Okay. Now, second problem. 2 moles of helium is heated at constant pressure from 10 degree to 70 degree centigrade. Find delta H in joule. Okay. See, delta H here it will be N. We know this formula, NCP delta T. What is CP? Heat capacity at constant pressure. What is indicated by that? That is heat required to increase the temperature of 1 mole of a substance by 1 degree centigrade. This is for 1 mole, so you have to multiply by number of moles. And this is for 1 degree centigrade change in temperature. For that, how much heat is required? So you have to multiply it by total change in temperature. Now, we know that Cp is equal to F by 2 plus 1 into R. Okay, where F is degrees of freedom. This is degrees of freedom. Okay. So, for monoatomic gas, this F is equal to 3. Translational, rotational and vibrational motion. Helium is a monoatomic gas. Therefore, Cp will be is equal to 3 by 2 plus 1 into R. That means it is 5 by 2 R. Now we put this value here. So our delta H will be is equal to 2 into 5 by 2 R into delta T. That means 70 minus 10. That means that is equal to 60. Change in temperature. Change in temperature will be same. Either you express in centigrade or in Kelvin. Right? So 2 gets cancelled. Therefore, delta H that is equal to 5 into R value in joules. So 8.314 into 60. So it is delta H is equal to 8.314 into 300. So I can write 831.4 into 3. That means how much it is? 3 3s are 9, 24. So it is 2494.2 joules. That is your delta. What is this value? This is your delta H. So delta H is equal to 2494.2 joules. Okay. Now coming to the summary of this enthalpy. That is, first point, enthalpy is the, already I told you, this is the measure of overall heat content or heat stored in the body at constant pressure, and it is equal to, already have seen that H is equal to E plus PV. Now, absolute value of enthalpy cannot be determined. What we can determine? That is, when the system goes from one state to another state, then this change in enthalpy that can be determined. Then enthalpy is a state function. State function means its change in value depends only on the initial and final state but not on the path followed. Then change in enthalpy will be the final value of enthalpy minus initial value. Then enthalpy is an extensive property, means its value depends on the amount of the substance present. Then enthalpy has the similar dimension of energy and its value depends on temperature, pressure and composition. Now coming to the relation between this enthalpy change and this internal energy change, that is delta E and delta H. What is the relation? See, we have seen that delta H is equal to delta E plus P delta V. Pressure is constant. Now we know that for ideal gas, this PV is equal to nRT. So what we can write? P delta V is equal to delta N, and this is for the gas, so I am writing delta NGRT, right? And this delta NG, look at here, delta NGRT, R is constant, T is constant, generally perform the reaction at constant temperature. So what is changing? Changing is the number of moles. That means number of moles of the product minus number of moles of the reactant. So delta Ng is equal to Np minus Nr. Okay. Now if we put it in this equation, then delta H, that will be is equal to delta E plus delta NGRT. So this is the relation. Delta H is equal to delta E plus delta NGRT. Right? Now this is the problem. Whether delta H minus delta E greater than 0 or less than 0 or is equal to 0 for the reaction. What is the reaction? Solid magnesium carbonate is decomposed to solid magnesium oxide and carbon dioxide gas. So here, what is delta Ng? Delta Ng, that is equal to number of moles of the gaseous product, which is only 1 mole of carbon dioxide, minus number of moles of the gaseous reactant, no gaseous reactant, so 0. That means it is equal to 1. Okay. So delta H is equal to delta E plus delta Ng R into T. Right? Delta Ng is equal to 1. So what we can write? We can write delta E plus RT. So therefore what we can write? Delta H minus delta E, that is equal to RT, which is a positive quantity. So therefore delta H minus delta E, that is greater than 0, and that means delta H is greater than delta E. Understood? So this is a little discussion on enthalpy. So it will help you to understand the other topics. Hope you have enjoyed. Thank you.